Oh, hello. So, in the previous class, what we completed the applications of the normal distribution one, right? Yeah, this is all we completed actually. Yeah. Now coming to the applications of the normal distribution, part two, like part two. So we'll start here. So after doing this chapter, that means unit 9 applications of the normal distribution too. So what are the things we will learn? We'll see first. So first we will use the normal approximation to the binomial distribution. So we'll use the normal approximation to the binomial distribution we'll use, and the normal approximation to the Poisson distribution. Approximation to the binomial distribution as well as the Poisson distribution. So both we will use here. Next, first coming to the normal approximation to the binomial distribution. So coming to the normal approximation to the binomial distribution, let x follows the binomial distribution. So what we are doing, we are assuming that x is following the binomial distribution with the parameters what n and p. For a large value of n and p in the neighborhood of 0.5, the distribution of x tends to a normal distribution with mean what? Mean is equals to expectation of x we can say, or else mu we can say, or else mean we can say. So the mean is NP and the standard deviation is what? Standard deviation is root NPQ. And the variance you already know square root of SD like standard deviation is variance. So variance is equals to NPQ. NPQ. So mean as well as the variance standard deviations are this. No, coming to find the probability of a less than x less than b of a binomial distribution by using the normal distribution. What we are using? We are using the normal distribution to find this binomial distributions. So discrete values a and b are are to be made continuously by subtracting correction factors. So correction factor will use what? Correction factor is 0.5. So we will subtract it, like we'll subtract it from the a and b, like a, and by adding to the b. So we are like subtracting from the a and we are adding that to the b. So from a it is subtracting and it is going to the b thing. Okay. So therefore, so probability of a less than equals to x less than or equals to b corresponds to what? Corresponds to what? So we are subtracting from this. We are subtracting half and we are adding to b plus half. So that's why here minus half and here plus half, minus and plus half for the normal distribution. So normal distribution, and what is the binomial approximation distributions? NCX, P power X, Q power N minus X. So we are writing in this form like X minus 1 by 2, probability of X minus 1 by 2 less than X plus 1 by 2. Here subtracting, here addition. So in this place, we will write how. So we have a formula, right? So what formula we have? A standard variable. That thing we need to do, like x minus mu by standard deviation. So we are using that formula only in these places. Normal variate we are using. So that is the thing. So now coming to the Poisson distribution. So normal approximation, how we will do the Poisson distribution, we'll see. So we know the mean of the Poisson distribution is lambda as well as the variance is also lambda. So the Standard deviation will become root lambda. The standard deviation will become root lambda. So x follows the Poisson distribution with the lambda for the large parameters lambda. So the distribution of x is approximately normal distribution with the mean and the variance. So p of x is equals to x what? So x minus from this x minus 1 by 2 and it is adding to this right side. So x plus 1 by 2. So this can be written as in the standard normal format like variant. So x minus 0.5 x minus 0.5 by sd by sd. Here if it is minus, this is plus here. Now, coming to the note, the normal distribution can be used to approximate to the Poisson distributions when lambda is large, best when lambda is less than 20. So when it is large, the lambda value is large, then it is used to like, it will be like easy to approximate, easy to find out that. So when x lambda is having the value of less than 20, I'm sorry, lambda is having greater than 20. They are saying larger, right? So larger means greater than 20. If it is having the lambda value, then it is easy to find out the approximations of the Poisson distribution. So next, coming to the normal approximation to the binomial distribution applications. So we will solve it by using an example. So it will be very easy for you to understand what we are doing actually. So what is the examples? There are 600 statistics students in the postgraduate classes for university, and the probability for any student to need a copy of the particular book from the university library on any day is 0.05. What they are saying, if any student wants to get a copy of the particular book from the library, university library, so what is the probability? The probability is 0.5, 0.05. So how many copies of the book should be kept in the university library so that the probability may be greater than 0.90? So for any person they are taking, that is 0.05. So what is the total probability that it should be greater than 0.90? Then how many students, how many books should we keep in the library? We need to see. So, and that none of the students who need a copy from the library has to come back disappointed. So, anyone's like the student wants any book from the library, they should not go with a like disappointment. So, it should be like if any person wants to take it, 0.05. So, how many they need to keep the books? So, we will solve it. We are given what we are given. N is equals to 600 and P is equals to 0.05. This is the probability. And 600 students, statistic students, right? N is equals. So what is mean? Mean we have a formula of NP, N into P. 600 into 0.05 is 30. Then what is the variance formula? Variance is NPQ. NPQ. Variance is NPQ. So 600 into P. So how we are doing Q here? So Q value is Q is equals to 1 minus P. 1 minus P. So what Q is equals to what is P? 0.05. So it will become Q is equals to 0.95. Q is equals to 95. So 600 into 0.05 into 0.95 equals to 28.5. Equals to 28.5. So what is the standard deviation? Standard deviation is root of this, right? See, which is approximately 5.3. We would like to find x1 such that, so what we need to find the x1. So we are taking this probability of x less than or equals to x1 and greater than 0.90. So it should be greater than the probability of all the students, right? So we are finding this normal variate, standard normal variate, x minus mu by x minus what mean, x minus we know z is equals to x minus mu by n standard deviation. So what is 30? 30 is the mean, NP, means mu. It means mean. So 5.3 is the standard deviation. So after calculating this is a form to represent actually. So next we are taking what we are taking, Z less than or equals to Z1 and greater than 0.90. For this Z1 we are taking the probability. So 0.5 And here it is 0.90. In between that, we are taking plus 0, probability of 0 less than z and less than x1. So less than z and less than x1. So now probability of 0 less than z less than z1 should be greater than 0. This should be greater than 0.90 because the students need a copy from the library, has who don't want to go come back or go back disappointed like that. So greater than 0.90 minus 0.5 less than 0.40. So we are taking from the normal distribution, which is approximately one. It is greater than 1.28. So in this place, what we'll take, this standard thing, standard normal variance should be equals to 1. It should be greater than 1.28. It should be greater than 1.28. So what happens now? So x1 is greater than 30 plus 5.3, what we got here there, the standard deviation, sorry, standard deviation plus into 1.28, 1.28, which is greater in the previous step, right? So after this 5.3 into 1.28 is 6.789. So 30 plus 6.789 equals to 36.784. So which is approximately to 37. So hence the library should keep at least 37 copies of the books. So at least 37 copies they should keep. So that every probability, like they'll have the total probability as 0.95 or anything. Next, coming to the other example, there are 100 true or false questions. What is the probability that guesswork will yield? So they are saying, what they are saying, there are 100 true or false questions. It may be true or it may be false. So what is the probability that the guesswork will yield? Like exactly 45. You are guessing. Actually, you are in a something anything. So you are guessing. So what is the probability of guessing 45 correct answers you need to find out, and 45 to 55 correct answers, both inclusive. You need to take inclusive. You need to inclusive. So less than 40 correct answers. So these are the three cases you need to find out actually. So coming to the first case. So first we need to find out the smooth regular things. So what are that we'll see. So let x be the number of the correct answers. So we are assuming correct answers is represented by x. So x follows the what binomial distribution, because we are taking true or false, right? By true or false, then we will definitely for sure will take binomial only. So means n is 100 there, and what is the probability p? P is 1 by 2 because two chances, maybe true, maybe false, like that. So first we'll find out the mean of the binomial distribution is NP. So we have how many? 100. So 100 into what is the probability that I have? 1 by 2 probability, because two chances are there, true or false. Any one true or false comes one side only, one time only. So it is 1 by 2. So 2 ones are 250s are. So what is NP? NP is equals to 50. So mu is equals to 50. Then, so coming to the variance is equal to what is the formula? NPQ we have, NPQ. So variance, N is what? How many numbers of questions are there? 100. So what is P? P is, we got 1 by 2. So what will be Q? I told in the previous question, right? P is equals to, or Q is equals to 1 minus P. So Q is equals to what? 1 minus half. 1 minus half is half only, right? So Q is also equals to half. Hmm. So it will be Q is also equals to half. So the answer becomes 50 and 25. So sigma square is equals to 25. So standard deviation is what? Standard deviation of like this is sigma square means variance, right? Root of variance is standard deviation. So it is represented as sigma, and variance of root means 25. Root 25. It is 5. So sigma is 5. Sigma is 5. So next coming to the, so we got mean value, variance value, and as well as the standard deviation. So what is the first question? Exactly 45 correct answers. What they are saying? Exactly 45 correct answers. So the probability of exactly 45 is written as x. Probability of x is equals to 45. It can be represented as 44.5 less than or equals to z, and it should be less than or equals to 45.5. Between that, we can take anything. So we will take what is the total? Like if we take 45.5 minus 50 means it is mean. So how it is written, right? So x minus mu by this. X minus mu by sigma. X minus mu by sigma. So x is 44.5 and mu is 50 as here we wrote. So sigma is what? 5. So that's why we wrote like this. So after that, so when we calculate this, it will be 1 minus 1.1, and if we calculate this 45.5 minus 50 by 5, it is minus 0.9. So approximately if you calculate this in the calc or any table like a normal distribution table, or this is not normal distribution, right? So you need to check in the table. So then we'll have the value, exactly value is 0.04839. So this is the value that the guesswork will yield exactly 50, 45 times, correct answers. Next, what is the second question? So 45 to 55 correct answers, both inclusive. So they are saying both inclusive. So we need not to take inclusive means 44 we can take and 55 we can take. Both inclusive we need to take. Okay. This is like this, both inclusive. So first same formula, x minus mu by sigma. So x is 44.5, mu is 50, and sigma is 5. So here 55.5, 50. So this is mu and sigma. So after calculating this, what we'll get? We'll get 1 minus 1.1, and this is 0.1. So we'll have an answer of 0.72866. Next, coming to the what is the third question? Third question is less than 40 correct answers. They are saying less than 40 correct answers. Probability that the guesswork will yield less than 40 correct answers is less than 40 we need to take. Probability of x is equals to less than 40. Yeah. So what it will become? So probability of z less, sorry, probability of z less than 40 plus 0.5 minus 50 by 4. So what happens? 0.40 plus 0.5 is 40.5 and minus 50 by 4. So this becomes like 59.5 by 4. Then it is a 2.38, 2.38, 2.38. So 2.38. So probability of z less than minus 2.38 can be written as 0.5 minus probability of 0 less than z and less than 2.38. So we can convert this minus into the positive here. So when we calculate this value, it is equals to what? It is equals to minus 0.4913. 0.4913. So 0.5 minus 0.4913 is 0.0087. 0.0087. Okay. So next coming to the, this is all about binomial, right? Binomial distribution. So next, what is the distribution we have? So we have the Poisson distribution. So with example, I hope like with example, you understood how to do the binomial normal approximation to the binomial distribution application. So now we will go for the normal approximation to the Poisson distribution applications. Okay. Example, in a particular factory, the number of accidents occurring in a month follows a Poisson distribution with mean 2. What they are saying? So in a factory, a particular factory, any factory, so the number of accidents occurring in a month, how many accidents are occurring, follows a Poisson distribution. So they are saying mean is 2. And the find the probability that there will be at least 22 accidents in a year. So they're asking like at least in a year there should be 22 accidents. So what is the probability then? Solution. Let X be the random variable showing the number of accidents occurring in a year. So year actually what they are saying mean is 2. So mean into 12 equals to how much? We have 12 months in a year, right? So it is 24 per year. So it is greater than 20 only. If we see, or 22, they said at least 22, it is greater only. So the Poisson X follows the Poisson distribution. Follows the Poisson distribution. So that is lambda is 24. So since lambda is greater than 20 only. So what they asked us to find out the probability of X greater than or equals to 22, right? So they told at least. So we can take at least 22 or as more as 22. So this is less than, not greater than or equals to. So it should be 22 or more than 22 it should be. So apply a continuous correction. So what happens for this? So we are taking here and we are adding there. So 22 minus 0.5 and this again becomes 21.5. So approximately what is the lambda value? 24 and sigma value is standard deviation is root 24. So we are taking probability of X less than or greater than or equals to 21.5. So 21.5 minus mu. Mu is what? Mean. Mean is 24. And the variance is what? This only. Standard deviation is equals to this. So in the Poisson distribution, the mean is sigma as well as variance is also sigma. And the standard deviation becomes root sigma. Sorry, I mean to say lambda. One second. So in the Poisson distribution, mean is lambda, variance is lambda, and standard deviation is root lambda. So what happens here? So we are taking the standard normal form variance. No, then we are calculating. So what we are calculating? So 21.5 minus 24 by root 24, root 24. Then it is the value of minus 0.5103. So which is approximately probability of Z is greater than minus 0.510 means it is equals to 0.6950. It is equals to 0.6950. Coming to the next example. So what is the next example? You guys try to do one. So I'll explain you, but you try to do. So what is the examples? So the number of defects per meter in a roll of cloth has Poisson distribution with a mean 0.25 and a Taylor by 300 meters of cloth. So what they are saying, so the number of the defect pieces per meter in the roll of a cloth is following a Poisson distribution with the what mean is 0.25. And the Taylor buys 300 meters for the cloth. The Taylor is buying the 300 meters of the cloth. So find the probability that the Taylor cloth will contain less than 90 defects. So what they are asking, so you need to find out the probability that the Taylor cloth will contain less than, it should contain less than 90 defects. So we will do it. So solution part, when coming to the solution part. So first you need to write what is given in the question, then you need to analyze and then you need to start solving it. So X be the random variable showing number of the defects per 300 meters, right? So what is the probability of what is the mean here? Mean is 0.25 and how many meters of cloth is there? So 300. So it is 0.25 into 300 is 75. So what is the lambda value here? So lambda is 75. So since lambda is greater than 20 only, then we can apply the approximation correction factor. So we are correction factor. So 90 minus 0.5. We are taking it as 89.5. We are taking it from here and we are adding it or subtracting it there. So the normal approximation, what it becomes, mu is equals to lambda is equals to 75 and sigma is equals to root lambda equals to root 75. Root 75. So here it's again coming to the normal standard variate. Normal standard variate, what is the formula? X minus mu by x minus mu by sigma. X minus mu by sigma. So x is 89.5 as we got here. So 90 we are taking minus. So minus 75 is mu value and root 75 is the standard deviation value. So after calculating 89.5 minus 75 by root 75, it is the Z probability of the Z less than 1.6743. If you are calculating this, we'll get 1.6743. So after solving these equations, like probability of Z less than 1.6743, we'll get 0.95296. 0.95296. So this is the diagram representing Z is equals to 0 and Z is equals to 1.67. Z is equals to 1.67. So, and probability that the Taylor path will remain less than 90 defects is what is the probability we are getting here? So, we are getting probability of 0.52, 0.95296. This is a probability that it has the less than 90 defects in the cloth that the Taylor buys. So, next read what is the question. So, what is the example of third question? So, the number of advice registering at least 2.5 on the Richter scale. So earthquakes are calculated in the Richter scales actually. So having an epicenter with a 40 miles of downtown, Memphis follows a Poisson distribution with a mean 6.5. What is the probability that at least 9 such earthquakes will strike in next year? So they are asking in the next year if at least 9 earthquakes are occurring there. So what is the probability? They are asking what is the probability that at least 9 such earthquakes will strike next year. So what we need to take? So the lambda is what? They gave mean value as 6.5. So you'll take 6.5. Then what they are asking at least 7. So greater than or equals to 7. 9 we can take. At least 9 they are asking. So less than, it will becomes 1 minus probability of x less than 9. So this, how it can be represented? It can be represented as z is equals to x is equals to 0, 1, 2, 3. So upon 8. So 1 minus, then what is the thing here? So if we calculate plus p of x is equals to 0, 1, 2, 3, 8, we'll get the value of 0.792. 0.792. So 1 minus 0.792 is equals to what? So it is equals to 0.208 equals to 0.208. Now, let us use normal approximation to the Richter's Poisson distribution to calculate an approximate probability. First, we need to take a continuity of the corrections we get. So what we need to take, the it is greater than or equals to 9, right? So we will take 9 minus 0.5. So 9 minus 0.5 is what? It is 8.5. So 8.5 can be written as, like, this statement can be written as the standard normal variance. It is a probability of z greater than 8.5 minus lambda by root lambda. So we know the what is mean, what is the like standard deviation, what is the x values here. It is in the form of x minus mu by standard deviation. So what is, after calculating the 8.5 minus 6.5 by root 6.5, it is equals to what? 0.78. It is equals to 0.78. So probability of z greater than 0.78 is equals to 0.218. So this is the thing. So what is the summary? We'll see. So use the Poisson distribution to determine the probability that x is at least 9 is exactly 0.208 or 218 208. So, and we use the normal distribution to determine the probability that at least 9 approximately 0.218. So if we do this by a Poisson distribution, we got 0.208. So when we do the normal approximation, what is the value? It is 0.218. So above Poisson, if we do, it is 0.208. So I hope you understood this problem. Next, go to the other problem. So what is the other problem? So if x follows the b, that is maybe binomial distribution. So any b, they are taking variables 20 comma 0.5. They are taking 20 comma 0.5 binomial distribution if you follows any variable. So they're asking to find out the probability of 6 less than or equals to x less than or equals to 10. So also find the approximation to the probability by using the normal distribution as well as the Poisson distribution. These two distributions we need to use to find the approximations. So what is given in for every question? First, you need to write what is given in the question. So it is x follows the b 20 comma 0.5. Then p, what is p and q? Binomial distribution or Bernoulli distribution. So we have uh, different things. So we have a binomial distribution here. So what is p value? P value is 0.4. 0.4. And q value is what? So q value is 1 minus p, right? So 1 minus p means 1 minus 0.4 is equals to 0.8. 1 minus 0.4 is equals to 0.8. So they asked what? They asked us to find out the probability of 6 less than or equals to x less than or equals to 10. So it lies between 6 and 10, right? So we will take 6, 7, probability of 6, 7, 8, 9, 10. So what is the formula? NCR, P power X, Q power. Tell me, what is the value? NCX, P power X, Q power N minus X, Q power N minus X. So we wrote the formula. So 20C, 20C6, 26, 20C6, 0.4 power 6 and 0.6 power 20 minus 6 plus 20C7, 0.4 power 7, 0.6 power 6, 20 minus 7 plus 20C8, 0.4 power 8, 0.6 power 20 minus 6. So we wrote this. And this is the ninth one. Ninth one as well as the 10th one. Same we wrote. So, so what is the values of that? Means for the sixth one, we got 0. 1244, and for the second one we'll get how you need to write means this also calculations. It is very easy. So 20 c 9 means 20 into 9 terms you need to take 20 into 19 into 18 into 17 into 9 terms you need to take, and down also you have to take 9 into 8 into so on to 1. So this like this you need to calculate into 0.4 into whole power 9 and 0.6 into 20.5 20.9. So if you do this 20 minus 9, so if you do this in the calc, it is very easy to calculate. So after sixth one, P of probability of x is equals to 6, we get 0.1244, and probability of 7, 0.1659, and probability of 8, 0.1797, plus probability of 9, 0.1597, and probability of 10 is 0.1171. So after adding all these values, we'll get 0.747. So what is the probability of this? The probability of this is 0.747. Next, this is using the binomial distribution. So how they are asking us to do the normal distribution also, right? So we will do the normal distribution. So we are assuming x is following the normal distributions with the mean and variance mu and sigma square. So mean is what? NP, right? NP is 20 we are having, and the P is 0.4. So it is 8. And variance is equals to NPQ. So 20 into 4 into Q, I told you like 1 minus P, if you do, it will be 1 minus 0.5. 4, it is 0.6. So it will be 20 into 0.4 into 0.6 is 4.8. So X is following the normal distribution with the 8, comma 4.8. Next, what they asked to find out the probability of 6 less than or equals to z, x, and less than or equals to 10. So we are taking probability of 6 minus 0.5, and it is hazard here. So 10. So this side we are taking and we are adding here 10 plus 0.5. So this will become 5.5 and this will become 10.5. So this is the standard normal variant as we are learning from the past questions. So z is equals to x minus mu by sigma. So what is mu? Mu is what? Expectation of x, that is mean 8. And variance is square root of variance. Square root of variance. Standard deviation is square root of variance. That is root 4.8. So for x is equals to 5.5, it will become x value will be 5.5 minus 8 by 4 root 4.8. Then it will be a minus 1.141. So if we take 10.5 minus 8 by root over 4.5, it will become plus 1.141. So what we will take these two values and we'll do. So after doing these two values, we'll get approximately like a 2 probability of 0 less than z less than 1.141. So after doing probability of 0 less than z less than 1.141, we'll get 0.3729. So if you are multiplying it with a 2, then we'll get 0.74858, which is approximately 0.46, because we are having 5 8, right? So which is equals to 0.746. So we observe this very close to the value found above. So what value we got? So in the binomial, like if we are doing, so it is what is the value we got in the previous previous method, 0.747. So we got 0.746 here. Okay, with a similar thing, a point. So next, coming to other thing, they asked us to do the Poisson distribution. So Poisson distribution means we need to take n is equal, lambda is equals to np. So np means what? 20 into 0.5, 4 is equals to 8. So we know the formula of Poisson distribution is e power minus lambda, lambda power x by x factorial. So we will find what we will find. So expectation of equals to 6, e power minus 8 we are taking because lambda is minus 8. Then we'll get the value of what? 0.1221. Similarly, so if we are doing for the 7, 6 is this 7. If you are substituting e power minus 7, lambda power x means 6 by 6 factorial, we'll get 0.1396. So if you are substituting the lambda value as 8, then it will be 0.1396. So probability of 9 is equals to 0.1241. And if you are substituting the lambda value as 10, then it will be 0.093. So 6 to 10, if you add everything, we'll get 0.625, which is a little bit of poor approximation we are using. So we notice that this is a poor approximation since you have n is less than 50 and the probability is less than 1 by greater than 50, sorry, greater than 50, and the probability is less than 10 to use a Poisson distribution. So this is the thing, we'll use the normal approximation as well as the Poisson distribution. So these are the exercise sums you need to practice this exercise. So in the summary, in this unit, we have introduced the applications of the normal distribution. The most important applications of the normal distributions are the normal approximation to the binomial distribution and normal approximation to the Poisson distributions. We have also discussed some example problems on approximations also. On the binomial as well as the Poisson also, we did some examples, right? So check your answers. So we have 6 questions and you'll have the answers also. So first try to do without seeing, then you check the answers. So next, what are the applications? So normal distribution 1 is completed, 2 is completed. Now coming to the applications of the other continuous distributions we can do. So what are the other continuous distributions we completed in the previous one? So we completed the gamma distribution, beta distribution, and Koch distribution. So these 3 distributions applications will do it now. So first coming to the gamma thing, gamma distributions. So after doing this chapter, like after completing this unit, so we will, what we need to learn, we will able to do the things like we will identify situations where gamma distributions are used, like where we are using the gamma distributions to estimate the parameters of the distributions, like to estimate the parameters of the distribution, that distributions we will estimate the parameters also. So introduction. In the fourth unit of the block, we consider the theoretical properties of the gamma distributions. In this unit, we consider some numerical examples that illustrate the properties of the distribution. So coming to the gamma distributions, in the continuous distributions whose range is 0 to infinity. The range is what? 0 to infinity. In life testing experiments, the lifetime of the component is non-negative. They are saying it is non-negative. Gamma distribution and its special case exponential distributions are widely used in life testing experiments. They are used in what? They are used in the life testing experiments. Mostly used in the life testing experiment. So example, if you see the example, so the daily demand for the milk in a certain locality for the month is known to be gamma variant. If the average demand is 60,000 liters and most likely demand is 5 lakh 99 like 9,000 59,980 liters, what is the variant of the variance of the demand? So what is the questions? The daily demand for the milk in a certain locality is known as the gamma variant, we are assuming. What is the average demand here? The average demand is 60,000 liters and mostly likely demand is 59,980 liters. So what is the variance of the demand? So they are asking what is the variance of the demand. So in the, if you know the gamma distributions, if you go through the gamma distribution, the mean of the gamma distribution is P by lambda. So P by lambda means we are having the P by lambda 60,000. So what is mode? So we did how to calculate the mode, how to discover, how to find the mode also we did. So the mode is what? P minus 1 by lambda. So which is what? Mostly likely demand, 59,980. So lambda is equals to what? 0.05 and P is equals to 1. So from these 2 equations, we can find lambda is 0.05 and P is 3000. So what is variance formula? Variance is P by lambda square, right? P by lambda square. So what is P value we got? We got 3000 by equating these 2 equations. So by these 2 equations, 1 and 2, by solving these 2 equations, we got P is equals to 3000 and variance is 0.05. So variance is what? P by lambda square. So P is 3000 and lambda is 0.05 square. So which is equals to 12 lakhs. 12 lakhs, which is equals to 12 lakhs. So same problems we'll do more. So they're asking the probability density function of the probability density function of the gamma variant is x of x, f of x is equals to 2 into e power minus 2x. So what they are saying, the x value is greater than or equals to 0 or else 0 otherwise. So what is the probability that x is more than 2? So if you are taking the x value is more than 2, so what is the probability they are asking? So first we will take f of x is equals to lambda of p by gamma function of p into e power minus lambda x per. We are taking x value is greater than 0 or equals to 0 and lambda value greater than 0 and p value greater than 0. So what is this function? This is a function of f of x. So from this we can calculate that p is equals to 1. In the place of p we can see 1 and lambda is equals to 2. That's why 2 power 1 means lambda place we are taking 2 and p place 1. Then p power 1, right? 1. Then e power in the place of lambda we are substituting 1, 2, x. So we got the same thing. So from this we can conclude. So p is equals to 1 and lambda is equals to 2. So they are asking probability of x greater than or equals to 2. So what we need to do, we need to take two integral part of 2 to infinity 2 to infinity f of x into dx. So what is f of x value? So 2 into e power minus 2x. So 2 comes outside. So integration part 2 into infinity e power minus 2x into dx. So 2 into, so for this integration, if we do e power minus 2x, we'll get the, after integration, we'll get e power minus 2x by 2. So for this, we need to apply the limit, so infinity to the 2. So if we substitute that, so e power 4 will get, e power 4 will get. So this 2 can be cancelled and if you substitute this 2 into e power minus 2 into 2, then we'll get e power minus 4, which is equals to 0.0183. Next, coming to the other examples, the water consumed in a building per month is assumed to be a gamma variant with a mean 40,000. If most likely demand is 39,933.333 liters, find the probability density function of the water consumed. How much water is consumed? We need to find the probability density function. So mean is equals to what? So mean is equals to p by lambda. So p by lambda is 40,000 and the mode is p minus 1 by lambda. So that is 39,933.333. So lambda value is what? From this lambda value is 1 by 40,000 minus 39,000 minus 933.333. Then if we calculate, if we subtract this, we'll get 0.015. So which is equals to 1, p is equals, we got the lambda value, lambda value is 0.015. So if we convert this 40 into 0.015, we'll get 600. So 600. So what is f of x? F of x is what? F of x is, we have a formula, right? F of x formula. F of x formula is this. We can see here. So lambda power p by gamma function of p e power minus lambda x. So in the place of lambda, we'll substitute 0.15 power what? P. So p plus 600 by gamma function of p means gamma function of 600 into e power minus lambda x. Minus lambda x means e power minus 0.015 into lambda 5 x power x means 600. So that is 600 or 599. So which is equal greater than or equals to 0. Otherwise 0. So like this we can find the probability. So this is the things we have completed today. So these are the gamma distributions. We have more examples actually. So more 2 examples. So after that, we will we complete in the next class. We'll complete the remaining examples and we'll go for the next distribution, that is gamma is completed, right? We have the beta distribution, so we will do what are the application comes under the beta distribution in the next class. So we completed the gamma as well as the normal distribution part 2. So next session we'll continue with the beta applications, beta distribution applications. Thank you.